computer.
So we had gone through these data structures last day, and we'll see implementations of these data structures today. First will be arrays. I'll use C++ as programming language. So for static array, simply we can like for any type data type of array, like if we choose int, we can simply define an array like this. Here will be the size, and if we want to use dynamic arrays in C++, dynamic arrays are defined using vector, and the syntax will be like this. Here will be the size, and we can define it can have variable size according to our input. And here is optional. Here is the optional value we can give if we want to initialize array with some value. Like if you want to initialize array with 10, 5, any value, all elements will be initialized with 10. So how do we use this arrays? I'll take a static array for now. So if you want to iterate, first we want to insert elements in the array. So we'll use any loop for while and anything. Like if we choose a for loop, and we'll go through from since its index starts from 0. So we'll choose I is equal to 0 and I is less than size of the array, like 20 here, and I plus plus, and we can insert in the array using its position. Like if you want to insert at 0th position, it will be ARR and in next step it will be ARR1. So it will insert at that position, and we can insert according to our logic, anything, function, something, logic, anything. Let's say we insert I only. So after inserting, we can, if you want to see output of the array, we can similarly iterate through all the values here. So we got values from 0 to 19, since I was 0 to 19 according to the indexes. And what all other operation we can do here, if we want to, what other operations are there? Okay, so this is a static array, and we cannot increase its size if we want. So for that, we have a dynamic array vector in case of C++. Let's say we define similar 20 only. Sorry. So it will work similar in similar way, but in dynamic arrays, we can like increase the size of the array. Like ARR, like it has a function, it has a function like resize, and here we will give the size of the new array that we want. What it will do, it will like relook up in the memory that where that space is free, and it will relocate complete array to that space. So the time complexity will be order of n here, because it will look up in the memories where new size space is empty, and it will relocate to that size. And what other functions this dynamic array gives is we can output the size like this. And another function we have here is push back, ARR dot push back. What it will do, it will Push here we'll enter any value like 15, any value. So if we use pushback, it will push new element after 20 size, like at 21st place. So pushback function will insert new element at the end of the array and the size will increase by one. Similarly, popback is also there in this popback. It will delete the last element of the array and the size of the array will decrease by one. So if we do pushback and then again print this, the size will increase by one. We can print the size. New size is 21. We had printed here till 20. So if we print till 21, 13 will be at the end of the 13. So, and if we do pop back here,
Did it delete 20?
no. Okay, 1, 2, 3, 4, 5, 8. Will you run it again? No,
I think size you need to increase in for loop, right? Below 1.
I have increased. Okay, what the fuck, man?
Okay.
Oh, sorry, 20. I printed size here also. No? So it is size of the previous array. Sorry. It is still 19. The size is 20. After doing pushback, size is 21 and the new array will be this. Okay. The values were till 19 here.
Yeah, 0 to 19, 20 values. Correct.
So, and if we do pop back here, similarly, the size will be here 19 here. Old were 20. Size is new size is 19 and it will print till last value. If we do 20, it will show error. Oh, we cannot access that. Okay, something is going wrong. Can directly also use size here, but we'll need to use type cost here. Okay. What other operations we can do on arrays? Push, pop. Okay. If we want to delete any insert at position not at the end, then what can we do? We'll have to reshift all the elements. We need to increase the size. we need to reshift all the elements and insert a new element at that position. The time complexity will be order of n here because we need to go to that L position and then we'll shift all the element one by one. You can do that by
Are these pushback and popback methods is
yeah.
implemented mainly in view of stack, is it?
In stack also pushback popback is there.
Like now, even we can use arrays also to act as a stack
Correct.
by using these methods.
Yeah, we can use. Let's say we want to insert new element at position 5. So first we'll increase the size of the array to 9, 21. Let's say we can start from last of the array. And we can copy the value then here are I plus 1 equal to previous value. It will shift all the value and
Okay.
at
Actually, it should
last,
be, I think, I minus minus one.
sorry, minus. Then at last we can insert at position any value that we have to vary. Let's say this 57 anything. We can have value. So if we print here dot size, so it should insert um, here, 19. Okay. So we can shift all the elements like this, and then we insert a new element. First, we need to resize the array also. So this is how we can insert at any position in the array. And if we want to delete any elements at any position, we need to perform similar operation. Like we need to first, uh, how we can do quickly is like we can shift all the values and delete the last element. If you want to delete any element at position 5, let's say, so we'll start from that position. We'll go till last, what is 21? 20 here. We'll say I is equal to I plus 1. So it will shift all elements with the, and after that we can use pop back. So it removed element at position 5th and shifted all the elements. So this was a static and dynamic array in C++. You can like see in your language also how it works. Functions will be similar, but syntaxes will be different. Next is linked list. Should we move to linked list?
Here in array search operation,
Yeah. Okay, search operation. If you want to find any element at given position 5, we need to like go from start into last element, and we need to check separately if if we want to search any value like 37, we need to separately check if ARRI is equal to 37. Then we can do whatever we like. Yeah, it will be order of n. Let me see.
so the search algorithms, like this will be a linear search, right? So
Yeah, correct.
take it up later.
What, sir?
That binary search.
This is linear search.
That
Yeah,
will come
correct.
also.
Linear. Those algorithms will come later.
Okay, fine.
But this, I think this is example of the static allocation, right? Array.
First, I told about static, then I told about dynamic also.
Okay.
And then, okay, we'll move to linked list now then. So, as we have seen, linked list has two parts. Like one part is data that we want to store, and another part is pointer to the location of the next node. So, how we can implement? We can have a struct, let's say node, and in that we can define data, and another, let's say next. Okay. To define a new node, we can use new keyword here, like node can be new node. If you want to initialize with the value, we can give a value here. And if we do not need a head node, we can use like this only. So let's say this is our head node. And if we want to add a new node, we can create a new node similar way, like a node new with value will new node. Let's say value is 10, and we can attach the head to the new node. Head next equal to node. In this way, we can attach nodes. And if we want to attach new node, then we'll need a pointer to this node. So we'll go, we can create a new node also, only pointer to the same head node. Like we'll just create a pointer that will point to header. And we'll use this pointer to iterate. So if we want to perform any operation ahead, one pointer will be there. So to go to the next pointer, we'll just say pointer is equal to pointer next. Okay. And if you want to add a new node, we'll say pointer next equal to similar. We can create a new node with any value, and you just say. And if you want to print all of the values, we have one pointer at head. We can use that pointer. Okay. Let's say we can use while for really. No type of head. It should give two values 10 and 20. Oops. Oh, we forgot to define
Node.
say what is this? Say value data value next. Okay. Yeah, okay. Next. Yeah. So we created a new head. So, and when we insert a new node, it will be start from head to the next. So we created new node. We given some value 10. It will initialize with the value and give the next to as null. And we given head to the next of head is node. Then we created another node, and we created that. We then gone uh, take we took our pointer to the new created node, and we then again created new node and added it as next. This way we can create a linked list.
So every time we have to update this pointer in our logic, right? Can't
Yeah.
we do updation of pointer in node struct itself?
No, we need manually. We need to do that.
Yeah. So whenever the new node is getting created, we can update that pointer in struct, right? Can't we do that?
If a new node is created, how will it get access to previous node?
Hmm.
We are just creating a new node.
We are having head
It
head pointer it also, right, inside node struct. So head will be different when the new node is getting created.
yeah, this node is different. We are separately creating this node. It does not know about this node. We're just creating two separate nodes and we are attaching those nodes.
Hmm.
So it does not have access to any previous or next nodes when we are defining the new node.
Okay.
So what are the operation we can do? We create a new node. We traverse node. Okay, if we want to delete, let's say we insert another node. So if we want to delete any node, we just need to remove this pointer location. Let's say we want to delete 20. We'll first go till 20, like in this loop. If let's say the value of delete this is equal to 20. So we'll check when our value is 20. What it will do, we'll define a new node. For deleting this value, we need to point 10 to 30, and it will automatically remove from our linked list. 20 will be separated, and when the function sync, it will automatically like removed. This memory space will be removed, or we can uh, use delete function to remove the memory space. So if we get to 10, how we can do is this is we can delete this.
So one
Got it.
question.
Yeah.
So in case of linked list, why do we need to use a pointers? Because the memory is not sequential.
Yeah.
I think in C++ there is concept of pointer, no?
Yeah,
In
but
C.
that is to refer the memory location, because linked list doesn't store the nodes in a sequential manner on the disk.
Hmm.
It's basically the memory address are not adjacent to each other. Memory addresses can be like far away also.
Yeah. If we want to store like very large data, we can use this. So we do not need to take sequential memory space in the disk. If it is free anywhere, it can take those data.
Yeah. So in case of C++, now we are handling through pointers to
Yeah.
point to the next memory address. But in case of,
Yes.
for example, other languages like Python, Java, they don't have a pointers concept, right? To refer to the memory.
Okay.
They have Python also have, PHP also have.
I think Java doesn't have pointer.
Java, I think, doesn't have, but Python
In
and
Java, we
PHP have.
can make use of address of.
Hmm.
Can have reference in Java also.
So does Java has pointers?
No pointer, not exactly pointer, but we can make use of address of. We can have reference in Java also.
Hmm. Mm-hmm. Yeah, please go on.
Okay. So we need to check which element has next value as what we want to delete, because we want to change that pointer of the previous element. So we'll check I is next of I value, and if its value is equal to what we want to delete, then we'll do I next is equal to next next. We can for to say like this, and if we want to delete that node, so first we need to get to that node. Let's say we define a new node here. Now, okay, we got to that node. We know this node we have to delete, and we change the link of previous node to next. So 10 will point to 30. We can simply okay, for deleting we can simply use delete function. And it is in C++, it will free the space of that newly created node. Then if we print again, Okay, it is not getting here only. So we need to check if next is present or not. If it is present, then only we'll check. Yeah, yeah. So 20 is removed from 10, 20, 30. We'll just go to previous node. We'll point that previous node to next one. So it will remove the linkage of middle node and will delete that node. This way we can delete any nodes from the linked list. We need to take care of if that value is present or not. It last time it had gone till last value, and it will, if we do not check it is null or not, then it will like show some error or unresponsive behavior. So we deleted, we inserted, we traversed. Okay, any questions? Should we go to next test structure?
To fetch element from linked list, similar to array, can we do like we can give the index and fetch, or
No,
how
no.
is it?
We need to traverse like this only, and we need to check here if that value is present or not.
For a single element also we need to traverse the whole linked list, right?
Yeah, correct.
Okay. Okay, can we have this code in some local file and then we can share later on? Just to
This
keep,
code,
yeah,
okay,
keep it in some file and then later on we can refer. Create in one VS Code, new file, paste it.
okay. Yeah.
Yeah.
So next data structure is stack. So like C++ has a predefined library for stack. We'll first see that, and we'll use linked list also to implement that. So in C++ standard library template, there is a stack function given. So we can define like this, any name here. And if it has operations like, if you want push operation, if you want to push any element, and if you want to iterate all the values, we can use any loop for or while, let's say. Yeah, to start from here, it uh, we'll have to start with begin. This will point to the first element. Sorry, not begin. It has the top. To get the top value in this standard defined library, it has a top function to get the top value. And what we can do every time will pop function will pop the last value, which is at the top. We'll do till stack is not empty. It has a function to check if it is empty or not. So, it's getting confused.
No, you're printing only I all the time. You're You're not
Oh,
changing.
yeah, okay. Sorry, yes. We'll define inside of this I equal to st dot top. Okay. Yeah, so we pushed 121. It is at firstly it will be at top, then 22, then 123. Then the top value will be 123. So the top is 123, then 22, then 121. You can iterate like this. And the pop function is removing the topmost element. So first 123 is removed, then 22, then 120. These two operations are used in stack top and pop. So we'll now implement this using simply linked list. We'll need to
The
add.
function to know the size of the stack.
Yeah, sorry. Yes. There is a function to know size of the stack, and that is on size only. Mm. But it will, if we do after this operation, it will show as 0 because we have popped all of the elements. So we need to do export position. First, its size is 3. Then we printed all of these elements. For that, we need to use pop operation also to iterate all the elements. So after iterating all elements, no element will be there in the stack, so size is 0. Okay.
When we are defining a stack, what is the default value for a stack?
It will
Or
be empty.
null, or like there will be some default value for that?
No. The size will be 0. There will be no element.
Okay.
So we'll now implement this stack using singly linked list.
What is better way? Like, I mean, using array, dynamic array, or using linked list to implement a stack?
Dynamic array. Okay.
I mean, any array or using linked list?
Best way is use that standard library that any language has given. Like in C++, there is library for stack. We do
Hmm.
not need to implement a linked list for that. They had already implemented them.
But in stack, I feel in stack the memory location will be adjacent to each other only, right? Not, I mean, no need to
No.
have.
It will be it will be implemented like a linked list only.
Hmm. Okay.
Okay. So okay. We need to implement a stack using linked list. This problem is is asked in many interviews also to implement a stack or use using linked list. So first we'll define a new node. And we'll add new values, new nodes. Okay, we need to use add this using operations. So we'll need to create two functions, push pop and one more function for printing the top value. We can also create size and other functions also, but these three are major functions: push, pop, and peak. Or we can say like to print the topmost value. we can create another class stack and we'll define a module. Say if we define new stack, then the head value will be no. And if we want to implement this functions for shop operation, let's say public, we can do. And it will have an argument of any new value that we want to push into the stack. What we'll do is we'll create a new node and attach that. We'll give that this value to that node and attach that node to our previous node that we had. So we'll create new node. Let's say its name is node. Its value will be val. Okay. Yes, and we'll attach this new node with the previous node. Let's say this, we say this is the top node. This was the earlier top node. Then we created a new node. We attached this node to the top, and we'll say the new top node is this newly created node. Just these 3 lines only. We created new node. We attached this new node to that our last node, and we said that the newly created node is our topmost node. So we can create a print function also here. We need to create first a pop function. So if you want to remove topmost element, what we'll do, the topmost element will have pointer to the previous element because we have inserted like this in this way. So we'll just go to the next element, like top, we define it, let's say we'll need to define a temporary variable top, and we need to delete this top element, means temporary. First we'll change our new top element. Top will be top next, and we'll delete this temp. So it will delete the topmost element, and we have moved to the previous element already. And here we need to check if there are elements there present or not. So we need to check if we need to create a new function, like we'll create if it is empty or not. So
What is the delete function here? Delete math. What?
the delete is a default function in C++. It will like erase this variable and free a space from the
Okay.
memory. If we do not use this, then that memory space will be allocated.
Okay, but in other languages, we need not to manage this, right? I think. क्या?
In some languages, we need to manage. In some we do not need to manage.
Got
We'll
it.
need to check it. Yeah. We'll create is empty function to check if it is empty or not. While doing pop function, first we need to check if it is empty or not. If it is empty, we will not do anything. If it is true, we will return this. And how we can check if it is empty? If the top value is null, so we will say there is no value in the stack. So we have implemented push pop empty, and we can implement peek function also. It will output the topmost element if it is not empty. If it is empty, we will simply just output stack is empty. And so we will just print top data. So if we define a new stack, we'll just do stack and in variable st. If we want to use push operation that we created, so any value is set 10, 20, 30. Okay, we can create one more function to print all of those values. Push up, or we can directly do inside of this one. The stack is not empty.
Is empty, no?
Yes, sorry. We'll do is equal to stack dot peak, or we can say top or peak anything, and then I just this like this only. So it should run, I think. Sorry. Yeah.
I think below you have defined I equal to peak that you need to remove. st dot
Where?
peak directly.
No,
Just
we need.
because you are printing directly there in the peak function.
Okay. Yeah, sorry. We just okay, we'll just do it. State dot peak. We do not need I here. Correct. Sorry.
No, for
Yeah, it is correct. But some warnings are there. It will first print 30 because we pushed it at last, then 20, then 10.
What is
STs
not
are some no return statements. Okay.
peak?
Okay.
Say
Here
peak
peak is
value or
a,
not
yeah,
return.
sorry.
Int,
You
int.
just output it.
Either you just return and then I equal to.
Hmm. Oh, it is not
I
defined.
you need that.
Here also return,
0.
no,
Return null you can.
-1. If it is -1, we will say that no elements are present. Yeah. So
And
push
for
operation, pop operation, peak operation, and is empty. We have created 4 functions here using linked lists.
Hmm. Nice.
Any questions on this? I will copy this. We created a struct of a node, and then we created another class for our stack. We defined a new node which is empty on define. We created push function. In this, we created a new node and we pointed that new node to the top. Okay, so it will be like this. So first we created a new node, which let's say this is our head node, nothing is there. We created a new node here with some value. We pointed that node to the top and we moved our pointer to this value. Now top is this value. Then we'll create a new node. We'll point this value to the top and we'll point our top to this value. So if we want to pop, we'll just go to this previous node directly by using top equal to top to the next, and we'll remove this node which we stored in temp. So it will remove this node. For checking if it has empty, if top is null, then the stack will be empty. For printing the value of the top value, we will just do top data. Okay. Should we stop here today,
Yeah, fine.
or we will implement key also?
And Atul, I have a question. Like usually we do this like from pointer to we get the value, right?
Yeah.
But do we do in the reverse way? In the reverse list, like with the value, do we use the pointer?
Uh, I didn't understand what you
So
said.
like we have the pointer value. So suppose first pointer you initiate, you have certain value.
Yeah.
That value will contain the next pointer.
Next pointer, yes.
Correct.
Initially,
And that
next
pointer,
pointer will be null.
correct.
Hmm.
And then the similar way it goes, right? So suppose I'm in the mid of the list.
Yeah.
Now certain value have 10 value. Okay. And
Yes.
I want to go in the reverse order.
We can only go in the way that we have defined our next. If next is
Next
this
is
way, then we can
mm,
only go in this way.
okay.
Or we can then use doubly linked list if we want to go previous also. It will have
Okay.
2 pointers like for
Next and
next and
previous and
previous.
previous, right? Okay. Okay.
We define in this way because we can easily like do pop operation and push operation. Okay, so we'll stop today at this point.
Yeah.
Sridhar sir.